Our topic is motion in a straight line, and this is motion in a straight line part 2. In part 1 I had discussed about distance and displacement. Now let me discuss about this average speed and average velocity. Average speed, V bar, written as V average. Average speed and average velocity. See, average speed and average velocity. What is average speed? How can you come to an imagination regarding average speed? So to come to an imagination, to have an idea, imaginative idea, what is average speed, we require conceptual definition. Conceptual definition gives us an idea regarding that one. And to solve problems, we do require mathematical definition. So I will give you these two definitions for average speed and average velocity. Conceptual definition as well as mathematical definition. Okay? Okay, and next, different important points to be kept in mind. I will explain you those points regarding average speed and average velocity. Okay? Later I will give you an example explaining these conceptual points, to check these conceptual points. Okay, and after that I will make one more video. In next video I will do some numericals, problem solving techniques while solving these problems here. Okay, now let us start the topic here. So what do you think about average speed? See, if a particle covers a distance of 30 meters, in 10 seconds, particle 2 covers a distance of 20 meters in 5 seconds, particle 3 10 meters in 1 second, and 4 80 meters in 20 seconds, in fifth one 100 meters in 25 seconds, and sixth one it is 150 meters in 20 seconds, seventh one some 90 meters in 30 seconds, like this. Suppose if you have a data like this, what are these? These are distances and these are time intervals, time taken for covering these distances. In this case, by looking at this, we cannot come to a conclusion which is faster or which is slower. Okay, so if anybody gives us a list of vehicles which can cover these distances in this much time, and if you are asked to choose one of the vehicle quickly in 10 seconds, it is difficult for you to choose. Why? Because you are having only two physical quantities here. One is distance, other one is time interval. Using these two, immediately it is not easy to find out which is faster and which is slower in this case. Which is faster and which is slower in this case. So by looking at this, we cannot quickly choose which is faster or which is slower. So we do require one physical quantity which immediately gives us an idea regarding which one is faster and which one is slower in this case. So let us check what is that physical quantity. That physical quantity is nothing but it is average speed or average velocity. Okay, average speed or average velocity. So let us check here what is the suppose this is the problem here. So we do require new physical quantities. So that's why these physical quantities, average speed and average velocity, they have evolved. They gives us an idea regarding how fast a vehicle is going compared to another vehicle or another particle. So okay, let us jump into the concept here. So okay, now let us see the physical quantity which helps us to find which object is moving faster and which object is moving slower, and that physical quantity is nothing but average speed. Okay, another one is average velocity. So average speed, it is a scalar quantity, while average velocity is, it is a vector quantity. It is having direction. Okay, let me give you the definitions regarding these two. There are two definitions. One is conceptual definition that gives us an imaginative idea what is average speed. So we can imagine, oh, this is called as average speed like this. So that is regarding conceptual definition. I will give that definition for both of these. And for solving problems, we will require mathematical equation. So I will give that one also. Two definitions for these two here. The first one is conceptual definition. Conceptual definition. So what is average speed? Average speed is defined as the distance traveled in unit time. The distance travels in unit time. For example, 5 meters in 1 second is equal to 5 meters per second. We write like this. So 5 meters is the distance traveled in unit time. Here unit time is 1 second. So 5 meters per 1 second is speed, average speed. Now what is the average velocity? That is the conceptual definition. Conceptual definition for average velocity. Average velocity is defined as displacement in unit time. This is known as velocity. So now, mathematical definition. This is average speed and this is average velocity. What is mathematical definition? So it is defined as average speed is equal to total distance by total time. So average speed is equal to total distance by total time. And here average velocity, it is defined as average velocity equal to total displacement. It is a total displacement by total time. Total displacement by total time. So we know what is the conceptual definition and we know what is mathematical definition here. So let us understand this in a better way. So let me consider this x-axis on which positions are taken in meters. So this is origin. I am taking a discontinuous line. Here let us choose a position A, let us choose another position B here. So let us consider a particle moving from A to B via point C here. Okay. So in this case, let us suppose that the particle is at initial position when time is t1 and it reaches final position B when time is t2. In this case, then what is the average speed here? The average speed is equal to total distance by total time. So what is total distance here? From definition of distance, the total distance is nothing but the length of actual path that traversed by the body. So what is actual path here? It starts from A and reaches B on this path. This is not the path here. So this is the actual path. So what is total distance? Length of path ACB by what is total time? Some delta t. That is the delta t equal to T2 minus T1. T2 minus T1 equal to delta t. Suppose at 10 o'clock The particle starts at A and by 10:30 it reaches point B. Then what is the time interval here? Half an hour, 30 minutes. 10:30 minus 10, final time minus initial time. Okay. So this is the case. So in this case, what is the average velocity? Average velocity is a total displacement by total time. So what is total displacement here? From definition of displacement, displacement is nothing but the shortest distance between initial and final points. Tell me, what is the shortest distance between 2 points? It is the length of the straight line joining the 2 points. It is the length of the straight line joining the 2 points, because any other line other than this straight line will be larger in size than this straight line. So between 2 points we can draw number of curves, number of lines we can draw, either rectilinear or curvilinear lines. Suppose you can draw this is a rectilinear line. See here, there are no curves here. Such type of lines are known as rectilinear lines. A particle can move on this path also like this. Let it be the any path here. So this is the ultimately this is the displacement line. You know this, because this is the, by definition, this is the shortest distance between initial and final points. So displacement is nothing but the length of the straight line AB. So what is total displacement here? Length of the straight line AB by total time is delta t equal to t2 minus t1. This is displacement. Okay, that's right. Now see here average speed and average velocity. We have come across two definitions. One is the conceptual definition, another one is the mathematical definition. And this mathematical definition, it helps us to solve problems here. See, now tell me. And one more thing is that here average speed is a scalar quantity, while average velocity is a vector quantity. Why this is scalar quantity, that is vector quantity? Because the average speed is defined as total distance by total time. Time is a scalar quantity, distance is also a scalar quantity. The scalar by scalar, it is again a scalar quantity. Therefore, average speed is a scalar quantity. Then what about average velocity? It is a displacement by time. Here time is scalar quantity, displacement is vector quantity. Therefore, vector by scalar is again a vector. For example, a vector 4i by 2. 2 is a scalar. So 2 goes here 2 times, so we are getting 2i. So a vector by scalar is again a vector quantity. Therefore, average velocity is vector. And one more thing is here average speed is always greater than average velocity. Average speed is always greater than average velocity. See, in this case what happened, this is position A, this is point, final point B, a particle moves like this. In this case, you know, so if the particle does not move in a straight line, then in that case, what about the distance and displacement here? Here distance is greater than displacement. If the particle does not move along a straight line from initial to final points, and if it goes about some other path, in that case what? The path length is always greater than this path length. Okay, what is this one? This is distance and this is displacement. So always distance is greater than displacement. When if the particle does not move along the straight line joining initial point and final point, in that case average speed is always greater than average velocity. Yes. Now let us check, is there any possibility if average speed is equal to average velocity? Let us check. So in which case it is possible? Suppose if the particle moves from A to B on a straight path. Okay, see now here, now this line is not a discontinuous line, but it is a continuous line here. What does it mean? Continuous line means it is the actual path on which the particle has traversed. This is the actual path on which the particle has traversed. So now what is distance here? Distance, it is nothing but the length of the straight line AB, because distance is nothing but the length of actual path. Here actual path is here, the straight line joining AB itself. So here distance is the length of straight line AB. Then what about displacement here? Displacement is always the length of straight line AB only. Okay. So here in this case, distance and displacement, both of them are equal. Distance is equal to displacement, both of them are equal. So when distance and displacement are equal, when the particle moves along a straight line. Okay, distance and displacement are equal. Okay, what if distance and displacement are equal? We are talking about average speed and average velocity, no? Okay, average speed and average velocity, they depend on distance and displacement, because they are defined in terms of distance and displacement only. Okay, no? So here in this case, when the particle moves along a straight line, distance is equal to displacement. So this fraction is equal to this fraction. Okay, this RHS is equal to this RHS. So therefore, this LHS will be equal to this LHS. That is, average velocity magnitude is equal to average speed. So here we can put equal to. So when average speed is greater than average velocity, when the particle does not move in a straight line joining initial and final points, average speed is always greater than average velocity. And when it is equal, when the particle moves along a straight line from initial point to final point, then in that case, average speed is equal to average velocity. One question is, if the motion, in this case, when the motion is not along the straight line, average speed is greater than average velocity. Is it sufficient if the motion is along a straight line? Then can you say that average speed is equal to average velocity? No, we cannot say. Why? Because straight line motion itself is not sufficient. We must stress one more word, that is, a motion must be along a straight line as well as it should be in only one direction. So another direction is not possible here. So it should be in only one direction. See here, in this case, the particle is having different number of directions. But when the motion is along a straight line, there are only two possible directions. If the particle goes in one direction without changing its direction, then in that case, distance is equal to displacement, and hence average velocity, average speed is equal to average velocity. Okay? Okay. Now what if a particle moves along a straight line and reverses its direction like this? If two directions are there in the straight line motion, then in that case, distance is never equal to displacement, and thus average speed is never equal to average velocity. So, okay, this is the thing. These things can be considered. Some examples will be given you. I will give you some examples. In those examples, we can get clarity regarding this thing. Next one is average speed. It is having only positive values, while average velocity, it has both positive, negative as well as a zero. So average speed can have only positive values, while average velocity can have positive, negative and zero values. Okay, and this thing also, it can be checked in the following examples. So with the help of some examples, let us check. I told you before, no? Average speed is having only positive values, and average velocity is having both positive, negative as well as zero values. And also we can check in which cases average speed is greater than average velocity, and in which cases both of them are equal. Let us check these examples here. See, in the following cases, find average speed and average velocity. Take time taken for the journey in all cases as delta t equal to 5 seconds. So, let us check here first. Suppose here a particle, it is moving from A to B. So, initial position is A, final position is B. So, it is going from A to B in this direction, no? So, what type of motion it is? It is a straight line motion, and it is in only one direction, towards right from A to B. Okay. Now tell me, in this case, what is average speed? Average speed equal to how much? Average speed equal to total distance by total time taken. So what is the total distance here? length of AB. Can I write length of AB? Total distance by total time is nothing but length of AB. Length of AB by total time. Length of AB by total time. So this is equal to, what is length of AB here? 7 minus 2 equal to 5 meters by total time is 5 seconds. So this is equal to 1 meter per second. So what is average speed here? Average speed is equal to 1 meter per second. Now what is average velocity? Magnitude of average velocity equal to how much? See here, distance, what is the distance here? The length of AB path. What is displacement here? The same length AB path. So here in this case, the distance and displacement, both of them are same. So average speed and average velocity, both of them are same. So average velocity is also equal to 1 meter per second. Got it? So when the motion is along a straight line in one direction, average speed is equal to average velocity. Okay. Now, what about this one? A particle moves from A to B, then B to C. See, A to B, then B to C. So in this case, what is average speed? Average speed equal to how much? See, what is average speed? Length of what here? So A to B is one path and B to C is another path. So what is average speed? Total distance by total time. So what is total distance here? Distance means nothing but length of actual path. So what are actual paths here? This is one path, this is another path. Two actual paths are there. So length of those two paths, that is AB plus BC by delta T. So total time is delta T. So what is length of AB plus BC? AB length is 5 and BC length is 2. This is 7 meters by 1 second is equal to, 5 seconds. So this is equal to 1.4 meters per second. Then what about average velocity? Average velocity equal to what? It is the length of, so what is average velocity? Total displacement by total time, you know. So what is total displacement here? What is the displacement? It is the distance between, it is the shortest distance between initial points and final points. What does it mean? It is the length of the straight line joining initial and final points. Don't think any other things rather than this. So just consider initial point and final point. We don't no need to bother about the original path of travel here. Just, so starting point is A, end point is C. So draw a line like this. So this is the length of this one gives us displacement. So what is average velocity here? In this case, average velocity equal to length of AC by delta T. So what is this? Length of AC by delta T. What is length of AC? 5 minus 2, 3 meters by 5 seconds. So this is equal to 0.6 meters per second. See here, what is average speed? 1.4 meter per second. What is average velocity? 0.6 meter per second. Both are same or not? Not same. What type of motion is this? Straight line motion. But direction, one direction or no? So there are two directions here. So body is coming back. So rightward direction as well as leftward direction. What do you know? If motion is along a straight line and in one direction, then only distance is equal to displacement. Then only average speed equal to average velocity. So if direction is not maintained in a single direction, if direction is not along a single direction, then what? Then in this case, the average distance is not equal to displacement and average velocity is not, average speed is not equal to average velocity. Got it? So next one, let us see this case here. See here, from A to B to C. So A to B to C. So what is average speed here? Average speed equal to total distance by total time. What is total distance? length of, so A to B means this one. This is one path. B to C means this is another path. Length of these two lines, that is AB plus BC by delta T. So this is equal to how much? Length of AB plus BC. So AB is 2 and BC is 5. So total 7 meters by 5 seconds. So this is equal to 1.4 meters per second. Now what is average velocity? What is average velocity? The average velocity equal to length of what? So actually average velocity equal to displacement by time, total displacement by total time. So what is the displacement here? A to B and C. What is initial point? Initial point is A. What is final point? C. So how to draw the displacement line here from initial point to final point? That is A to C. Put arrow mark here. See, arrow mark is always away from initial point. So initial point is here, arrow mark is in this direction. So this is displacement. So length of what here? Displacement, average velocity equal to length of AC by delta T. That equal to, what is length of AC here? 3. So since it is in leftward direction, let us take minus 3 meters by 5 seconds. So this is equal to minus 0.6 meters per second. Okay, what do you know? So in this case, average speed is positive and average velocity is negative here. Let us take this one. So here, the average speed, equal to what? Total distance by total time. So what is total distance here? How the particle moves here? From A to B to A again. So A to B is one path length and B to A is another path length. So this is equal to length of AB plus BA by delta T. What is the length of AB plus BA? So AB is 5 and BA is 5. So 10 meters by 5 seconds is equal to 2 meters per second. So what is average speed here? 2 meters per second. Then what is average velocity? Average velocity equal to, see, so total displacement by total time. So displacement, we have to draw line from initial point to final point. What is initial point? Let me start here. This is initial point here. So where is final point? No need to bother about other points and no need to bother about actual path. Where is final point? A itself. So no need to draw any line. Okay. So we are left with this dot. What is the length of the dot? 0. So what is this? Average velocity equal to length of A to A. Okay. So let me write otherwise. So 0 by delta T. Directly 0 by delta T, that equal to 0 meters per second. So I am giving you clarity now. So first one is, if distance, average speed and average velocity, they depend on distance and displacement. Okay. So in this case, average speed is equal to average velocity. And in which cases do you know? When distance and displacement are equal, when the motion is along a straight line in one direction, then displacement is equal to distance. And automatically what happens? Average speed is equal to average velocity. Similarly, in this case, see, motion is in one direction or not? No. Motion is along straight line or not? Yes, it is along a straight line. But it is not in one direction. From A to B, it is rightwards. From B to C, it is leftwards. Here, two directions are there. Then distance and displacement, can they be equal? No, they cannot be equal. If distance and displacement are not equal, can average speed and average velocity be equal? No, not equal. Because they depend on distance and displacement. Okay. So here also, the direction is first towards right, then towards left. In this case also, see, we got two different values for average speed and average velocity, so they are not equal here. So in this case also, two directions are there. Motion is in a straight line, but two directions are there. So we got two values for average speed 2 units, 2 meter per seconds, and average velocity 0. So two different values. So it is, we can come to a conclusion that if the direction of the motion is along one particular direction in a straight line, then only distance is equal to displacement and average velocity equal to average speed. Okay. If it is not along same direction, if direction changes, then in that case, never distance is equal to displacement and never average speed is equal to average velocity. They are not equal. So we have seen here. And one more thing, I told you before, average speed is always positive, while average velocity acquires positive, negative as well as 0 values. So let us check here. So in this case, what is the average speed? 1 meter per second, positive value. In this case, average speed 1.4 meters per second, positive value. In this case, average speed 1.4 meter per second, positive value. In this case, it is 2 meter per second, it is positive value. But let us check here. Average velocity, it is positive here, 1 meter per second. It is 0.6 meters per second, it is positive here. See here, it is minus 0.6 meters per second, it is negative here, and here it is 0. Okay, so it is very clear that average speed is always positive and average velocity can acquire positive, negative and 0 values. Got it, guys? So in the next video of this topic, that is average speed and average velocity, I will give you some numericals. I will explain you numericals, how to solve them easily. Okay.